I am thrilled about our next speaker, Brian Dolan, who's the CEO of Verdant.AI, and he's got an extended keynote to take us right into the executive roundtable, which kicks off right after. He has an amazing background and story, and I'm going to let him share it in his own words.
Okay, cool. Well, thanks for calling on me to come in. I'm sorry I was a little bit unprepared. I was sitting here gnashing on a piece of bread and not quite ready to talk. So I apologize for seeming a little bit out of sorts for just a second. I have my screen kind of split in a weird way. So when I'm looking at my slides, do I appear to be looking at you, or do I look like I'm looking off into the distance? Is that okay? I mean, I'm going the right way?
I think you look fantastic. It works for me.
You.
Yeah.
Okay.
No, you're looking at us. You're good.
Okay, good. And I can't see the chat window, so somebody please call out if there's something that comes up. Because we have a little bit of extra time, it'll be wonderful if people ask questions. I really enjoy more of a conversational style. Let me turn off my phone real quick. Sorry about this, guys. Yeah, please, if there are questions that come up, please ask them. I like to talk to people, which is why COVID really sucks, because I don't get to talk to people very often. So let me kick off a little bit about what I am and what I am, who I am, and what I want to talk about. Today, I want to talk about over-the-top media. OTT is sort of industry shorthand for over-the-top media. I'm not especially in the industry, but I have friends who are, and that means media like content or films or shows that are delivered directly to consumers. Probably the examples you know best are Netflix sending you direct content. You subscribe to them, they give you the content directly. And the NBA or other major sporting leagues allowing you to watch games directly over from a subscription service rather than having to tune into a network or something else that's going to intermediate for you. So that causes a whole sort of interesting analytical problems that I'm going to talk about today, and I'm hoping that it'll sort of inspire you to think about AI and other things we can do as analysts. Okay, let's see, get down here. All right, so who is Verdant.AI? Verdant is a mathematical products company. We like to build maps to the path of innovation in artificial intelligence. We usually work with large enterprise partners to do complicated products. We like to tackle things that seem next to impossible. And we like to do it using mathematical methods from the sublime to the ridiculous. So every once in a while, we'll call three friends and ask them their opinion, and that's our model. And every once in a while, we'll involve, systems of partial differential equations or neural nets or whatever it needs in order to accomplish the task. I've been doing this for about 25 years. My career, I've built over 3,000 products, and I have a lot of breadth in my experience. I have a little bit of depth in things like online advertising, national intelligence, and digital health, and clean economy, the clean economy using sustainable growth and stuff like that. So I have some background there, but what Verdant really does is pick problems that are challenging and intimidating so that we can try to tackle them using sophisticated analytics. Throughout this talk, you're going to see this little guy on the left. He's our analyst who has a problem. And over here on the right, you're going to see this little campground, and that's our engineering department that tries to help them sometimes, and they both have differences of opinions. So I tend to talk really fast, and I'm trying to slow down, so please jump in if I'm going too fast, especially if I've had coffee, which I haven't. The topic today really is about making decisions under uncertainty. And for us, that means primarily that, I'm getting some people in chat here. Okay, thank you for going slower, I will. And I'm getting that from a trusted friend, so. So we're talking about decisions under uncertainty, and that really brings a lot of sort of mental furniture along with it when you're thinking about how do I make a prediction for tomorrow, or how do I establish my business. In this context today, we're going to talk about over-the-top media suffering from the curse of big data, wanting to use that data, but also having a lot of issues that they can't quite use the data to handle, and trying to be guided by both instinct and data. Not only what do you have in your database already, but what can you conceive of for the future? That's a lot of what forecasting and modeling is. And then I want to talk to you about a bunch of the mathematical frameworks that already exist that have been around for 70 to 100 years that balance this world of conjecture and data. So first of all, what is the curse of big data? So the curse of big data is something you've probably heard before. It's a term that's been used for about 10 years, maybe 15. Actually, I guess I heard it at Yahoo for the first time in 2005 or something. But the idea is you have so much data coming in that any ridiculous hypothesis you might have about the world can be validated. And OTT has recently, over-the-top streaming media, has recently started to suffer from this as they've delivered their content directly to consumers. And those consumers have to, and those consumers push back data about how they're actually interacting with it. The stop and start times, if they've shared it on Facebook, where in the world they're consuming it and whether they're consuming it on mobile. So as this data comes in, it becomes completely overwhelming, especially to an industry that hasn't had the big data problem previously. And I actually find that fascinating because this industry has been very much model oriented, has been very analytical in terms of how they want to address their forecasting. And now they're being told, hey, you have data, you should make data-driven decisions. And of course you should make data-driven decisions, but there are places where that doesn't really help. So we need to turn to AI to make sense of this huge stream. So when we get into this, we kind of get driven into two camps. When we have a lot of data coming in, we get driven into two camps. This is a very common thing that happens in technology. On the left, we have the engineering-driven AI efforts that the lingua franca of the engineering-based AI guys is Python, in the same way that the lingua franca of the business analysts is Excel. So on the left, they want to say things like, data or it didn't happen. That's a very valid point of view. Didn't happen if we didn't measure it, we didn't capture it. I don't want to talk about it unless it's in the data. But at the same time, if you have that data, you've already captured it, you kind of already know the answer. A lot of the talk today around, a lot of the talk in general is around neural networks and deep learning. And those methods that are all very data intensive, these very data hungry methods, they're all very powerful methods. I have a couple that I really, really love. But they all rely on having historicals that were properly collected and properly managed before we decided to do some sort of effort, sort of learning against them. And so when you're doing that, you're basically asking your data, is there a cat in this picture? Yes or no. On the right-hand side is, excuse me, the business analysts who have been working in Excel and have to do forecasts. And they're being asked to make predictions about the future that they don't have data for. The future hasn't happened yet. And when they're being pressed like this, they have a mantra to up in here, the worst decision is no decision. You can't just not project for tomorrow. You have to do the best you can and come back to it. But again, the questions that are being asked are unanswerable by the given data in general. You can make an inference, but you cannot answer them. You just have to guess. And in the middle is the missing framework. Like, how can I take my best guess with what I want to do and where I think the world is going to go? And how do I use data to inform that in a way that is not exclusive? So I can't predict anything I haven't measured already, because that's going to happen a lot. But also in a way that's not just completely ridiculous, where I'm going, well, I think it's going to rain frogs tomorrow. Let's see, I'm getting more chats here. What about changing norms that aren't reflected by past data? I think Jay, I'm not sure who Jay is, but I very much believe that is the big problem that we're not seeing. I just got off the phone with a guy in mathematical finance who was talking about trying to use Markov chains to predict stock prices. And one of the things we talked about, let's see, I was just gonna go really technical. Part of our conversation was whether or not the information, including the variance structure of the different assets he was trading, like when this asset moves, does this asset move? Those variance structures are probably not captured in the data he's collecting. So the past data really doesn't know anything about tomorrow. Yesterday knows nothing about tomorrow in many valid data sets. So there are these theoretical frameworks that have, again, have been around for a long time. I'm going to show you some of them now, and I'm going to try to convince you that they're worth learning. The land beyond Excel and Python. So in the lower left here, we have our analyst who is setting out to try to get a more data-driven approach to his life. When he first starts to play with data, he goes to the places that he's comfortable, which are univariate statistics. He's going to take a mean, a min, an average, a standard deviation, or linear regressions, where he's going to say, well, it's been going up over time, so it's going to continue to go up over time, or other simpler regressions. And he's probably frustrated by that because he feels there's got to be a more scientific approach to all of this. So he'll go to his engineering department, which is in a nearby campus he's wandering, and they'll bring him these data-driven approaches, which again are all valid, very interesting. Computer vision is one of these things. Deep learning is another. Natural language processing. A lot of these things are getting quite mature and are very popular in the AI community. About 10 years ago, neural nets and deep learning became the rage, and it's often sort of spoken of as that is what AI is. I tend to disagree. And I'm going to show you why I disagree with that statement in a moment. It is a very valuable part of artificial intelligence, but our analyst, does not have any access to these methods and doesn't have an understanding of why they might be useful to him. Probably nobody to help them. So out beyond Excel, you can get into really interesting fields of study like game theory, network analysis, stochastic control is one of my favorites. Shapley values come from econometrics, and strong AI. And strong AIs, things like when we're trying to develop an artificial general intelligence, even that the AGI world is rather dominated by deep learning right now, but it's an interesting field in and of itself. So these other methods probably sound rather foreign. A lot of business analysts probably heard about them in B school and were like, whoa, I heard about Shapley values, I heard about econometrics, I heard about Pareto curves, but I don't really know how to use them. And so let me walk you through some examples to motivate you, if you're going into AI, to understand how large the space is and to see what other business analytics are possible. So I'm going to kind of try to build in sophistication as we go. So over the top media, oops, it's not quite lining up, is it? Come on, be like that. Over the top media delivers everything, right? If you're delivering a basketball game, you're delivering that basketball game. If you're delivering, a show, it's delivering that show, and it's delivering it through the platform and has access to how you are interacting with it, as I said before. So with computer vision, I can see what the user is seeing at any moment or event. So if they hit pause, I know that they were looking at a bicycle. I know that they were looking at a traffic light, or I know that they were looking at some celebrity on the screen right when they hit pause. Or when they back up, they're backing up to the scene with the Eiffel Tower in it or something like that. Additionally, with the speech to text ability, the sound can get translated into text, and I can process that text using natural language processing. So natural language processing is a whole field of trying to take text and turn it into meaning, identifying from as simple as identifying that this is a noun or that this is a person. You step that up to this is the person I was talking about in this sentence. You step that up to this is the topic of this sentence or this topic of this paragraph, and step that up to I have 1 million documents or 1 billion documents, and I want to know what the major topics within that corpus is. So you can make all these analyses are now possible and over the top because they're collecting the data and the technology exists. So you can look at every script that was ever delivered by Netflix and do some clustering on it if that's something that's interesting to you. Now, I want to manage expectations on that because even in human-to-human communication, we're asking for clarification all the time. No matter how clear you think you're being with your kids and that they have to brush their teeth, they are going to ask you for clarification or pushback. You're going to talk to your coworkers about how some process needs to be done, and they're going to misunderstand or incorrectly understand what you've said. So even with the computer vision and the natural language processing and any other mathematical framework we decide to use, we're going to have this problem of having to go back to the system and say, what did you mean? Or it's going to have to learn to ask us that. This is a Zoom meeting, and so I want to use this as an opportunity to have our obligatory wiener pick down in the lower right corner. That's Norbert Wiener, one of my favorite cyberneticists and mathematicians ever. And he was the father of cybernetics, and he constantly went on about all systems are limited by the information that is accessible to them. And he has a fascinating passage in one of his early tomes about no two systems can communicate if they don't share the same dimension of time. And I love that as an analogy that there needs to be a dimension, a shared dimension of communication between any two systems, between two people. Time is the most rudimentary one, but even other dimensions that are interesting are like language. It's hard to communicate without language if we're over a telephone, right? If we don't have a common language. If we have an interpersonal meeting and we can't hear each other, it's hard to communicate without the dimension of facial expression. So when we're talking to these AIs, we need to be careful about what sorts of, or we need to be cognizant of what kinds of information travel from us to them and back. I wrote a chapter in a textbook that just came out around these informational pathways. So I'm happy to give you a link on that guy. So social listening, clearly a big part of the over-the-top market, because people are looking into what people are saying on Facebook and Twitter, and YouTube. People are sharing, liking, retweeting. Those events can be captured easily because you've logged into YouTube or you've logged into Facebook. And now when I share the AI Showbiz link, the AI Showbiz gets a signal saying, hey, this was shared back, or at least Facebook knows. It may or may not tell Molly. To those social listening cues, as I share them or as I push them to other people, that creates a graph. It creates not only a social graph, but it creates a content graph as well. And when I'm doing my listening, as the people are sharing things, I can uncover what interests them. As a matter of fact, in the middle of the screen, there's this search bar from Netflix. And Netflix has the opportunity to read through search results that are coming in and say, people are searching for various celebrities or various topics or more like this. And there's a rumor that that's how Robin Wright got cast into House of Cards, is that people were wondering what she'd done after The Princess Bride. When you collect these things and you collect these graphs, you want to now do some processing on these graphs. So I've mentioned this thing down here called iGraph. iGraph is a graph processing system. It allows you to ask graph questions about your data as opposed to just storing it in a graph database. So a lot of people today are interested in this thing called Neo4j, which stores the graphs. That's a very valuable technology, but it doesn't process them. It doesn't ask you to say, where is a dense cluster of users or a dense cluster of content? Once I have those things identified in a graph and I can process it from econometrics, we know of this thing called Shapley values, which I mentioned earlier. One of my favorites, we're using it right now in a big project for an over-the-top company. And the Shapley values allow you to identify who are the key drivers in a particular team. Like in this example, who has the yellow jersey? Who is the guy who's really making wins? When you have a bunch of data come in, and we have an example now where we have 200 elements coming in billions of rows, we want to know which of those 200 elements is really driving revenue, is really driving subscription. And a simple way to be would just be regress on it or see what the big ones, what the big values are. But that's too simplistic, and it ignores the correlation effects, the interaction effects of having this person with that person, this variable with that variable. And Shapley values apply some insight into those sorts of drivers and the players. And I'll point out that the Shapley values were developed 60 years ago. I don't remember, like 1960 or 1970. By Lloyd Shapley, and he won the Nobel Prize for this method. It's a very powerful method. It's been used again and again, but it's largely ignored today because it seems a little bit strange. We have the formula right there in the middle for it. It's not particularly hard to understand. It's a little bit hard to compute. I'd say it's a lot hard to compute. I think one of our engineers is on. He'll probably say it's a lot hard to compute. So did I skip one? No. Okay, so content is still king. As we're looking at these things, we're looking at our graphs and we're trying to figure out who is sharing what. We still know that content is the number one thing that drives, drives viewership, drives engagement. So I'm going to back up and talk a little bit about games. A game, mathematically, is anytime we have one or more participants interacting with a system, and when I make decisions about that system, it affects somebody else also participating. So that can be in a cooperative way, it can be in a competitive way. So game theory is a very mature subject around how systems, when they're being manipulated by multiple people, will create these dynamics. And how do we model that? How do we try to figure out what the dynamics will look like before we push any data at all into them? So of course, the obvious place that you think of is video games. And the video game industry has been spending a lot of time trying to manage the button mash, just gameplay combat to the narrative ratio. That's probably one of many ratios they're trying to optimize. If you look at titles like God of War, which I recently sat down with my son and played for a number of hours. It's a fabulous narrative. It's a fabulous world, and it has some really great button mash. And that's no accident. A lot of the major titles are focusing on narrative, focusing on gameplay, and trying to understand how they can get the player through the experience and keep them engaged. They use a non-player character AI that is actually crippled, so they want to reduce the ability of the game AI in order to let the player experience the whole story and have the right amount of resistance. You could set your difficulty level, and that's reducing the game AI. And the way they do it is a lot of times they call it decision trees, although there's some really interesting work around these things called behavior trees that has been around for about 5-10 years, and I don't think it's that pervasive yet. On the narrative side, whether you're producing like a docu-series or a regular movie, you're trying to get the narrative over raw footage ratio, right? We know from reality TV that you can turn a person from a hero into a villain very, very easily just by simple editing. I have a good friend who I think might be in the audience now who does this for a living. I won't out him, but he knows that he can make anybody, that's probably him bringing in now, anybody he wants to in his shows, the bad guy or the good guy. So these creators are playing a game with their audiences that can be modeled and analyzed and even procedurally generated. So what does it mean to procedurally generate? That means I can take content that you already have and create new content around, whether by using the assets that you have in a new way or just generating entirely new assets. A lot of video games create new environments to allow you different play every time you come back into the game. So that procedural generation requires a fairly sophisticated model of what needs to be transferred. And that's not something that we know about in the data. That's definitely an instinctive thing. Some creator has to say, like, over here, I need to transfer the tree density or the bad guy density, the orc density, or even the cloud formation that I had. I need to transfer that along. That's a very instinctive thing that can be pushed into these mathematical models of games and control theory. Over here on the right-hand side, I have the Lorentz transform, which is probably the most famous thing for mathematics in the last several decades, because that's the butterfly effect. It comes from the notion that small systems can grow very, very big and can go out of control very easily. And as I think recent media, which I'm not going to reference specifically, will tell us, is that the audience loves a narrative that can kind of go out of control, but not so far out of control that it becomes unbelievable. It has to maintain this parameter within a set of ideas that will let them sort of follow the narrative along. I'm getting lots of questions, so I have 1 or 2 more slides, and then I'm going to get back to questions. So I know I said interrupt me in the middle, but I want to make sure that we get to all of them. Actually, let's take a quick look. There is a level of believability, it's true. So let's see, let's get rid of this real quick. And I promise I'll come back to these as time allowing. So the Lorentz transforms in chaos theory are part of what it came out of what's called control theory. Control theory is what was studied by the early Rocketeers. So even the button mashers right now are benefiting from what was called AI back then when the Navy set up their research labs and decided to come up with these control dynamics that have evolved into current methods in AI. Some of the neural networks are actually benefiting from this stuff that was historically fairly complicated. The Lorentz transforms themselves kind of look, depending on your perspective, if you're looking at the equations down there, they look simple or they look hard. If you're not mathematically versed, if you haven't spent a lot of time in mathematics, they probably look hard. But once you reach an undergraduate level, you look at those and they seem very approachable. So it's not that the math is so hard, it's that the thinking around the math has not been percolated out into general analysts. But because we have this opportunity to merge data and theory, especially in OTT, there's no reason we can't return to these things and use these as models to go forward. So now let's talk about the other kind of online game, the one that most people think about when you think of games, and that's professional sports. As I said before, OTT media owns the stream, and that means that they own all the events within the stream as well. So there's licensing issues around, can I write a book in Vegas? Can I write a book around a thing that just happened in a game because I don't own that game? So the stream itself has a whole bunch of events that are occurring within it. And there's this notion of event detection. My buddies at Stainless AI do this very, very well, where they can tell things like, has there been a touchdown? What's the shot percentage from this area? What's the, the ball pass through the strike zone? They're able to take this streaming sports and immediately categorize it. So you have all these data that is enriching this stream of this that they now own and now they can manipulate. So they're living in a much richer environment. And you couple that with the notion of fantasy sports, valuing teams and players as assets, right? That's what fantasy sports has been doing. It's a very lucrative market, and they're trading them almost like on the stock market. So if you can blend this event detection, knowing exactly what happened, when it happened, without having to have a human identify it, with this valuation, now we can borrow a bunch of techniques from mathematical finance. Mathematical finance is one of the more famous results from mathematical finance is what they call the Merton-Scholes, black Merton-Scholes equations, or I think they call them Black-Scholes a lot of times. That's one of the more common ones. Those are all variants of a thing called the Ito equations. And so the Ito equations on the lower right, that's the Ito integral, and above that is the Black-Scholes equation for the velocity of an asset. And what do those things describe? Well, they describe what is the possible price of, say, say we'll make it easy. It's the possible price of oil in 10 days. Well, that's a random process because so many things are happening in the market. You don't really know the answer. You can kind of guess at the answer, but it randomly wiggles up and down. And so it's a stochastic process. A random and stochastic can be used interchangeably many times. It's a stochastic process, but that creates a little bit more complexity than just trying to draw a line between two things. So the Ito equations are ways to predict the future under stochasticity or under uncertainty. So it's the mathematical finance guys have a lot of very advanced methods that they've been using for decades in order to identify these pricing models. And we can borrow those because now in the OTT world, we have that marriage of real-time, very fast-moving data. We have this event detection that allows us to generate the data and enrich the data stream into something that's useful. And we have the math to do it. So if we want to do our futures pool on LeBron James, it's a very easy thing for us to do. It's a very approachable dynamic we can try to accomplish. Let's see, get over here. So for me, this is my final sort of content slide. For me, this is the most interesting thing. I like to talk about how art reflects life sorry about moving that around, is similar to the fact that AI reflects culture. So in art, we have these levels of abstraction that are really, sort of dealer's choice. The artist, we spent centuries trying to be able to be photorealistic. And if you look at this image on the left, the John Bader oil on canvas, that's actually oil on canvas. This man painted this picture that is photorealistic, and it comes up as a classic example of photorealism. On the right, we have an extremely abstract view of a still life as well. This is, I believe, a lemon on a table. And so that's Picasso, who has abstracted away from reality and only seeing what he cares to see. So art, we're very comfortable nowadays with that notion of art being very real or very abstract. And it's reflecting life. We like to say art imitates life, art reflects life. Well, artificial intelligence is about the intelligence part, about the decision-making part. And decision really is culture, right? It's not biology, it's not reality, it's not physics, it's culture. So AI reflects culture. I think there's no getting around that. We've made lots of different ways to be very, very abstract and very, very concrete. Microsoft Tay, if you don't identify that image in the lower left, that was Microsoft Tay. And if you don't know the story of Tay, very fascinating story. People called it a disaster. I thought it was amazing. I thought it was actually a bit of a triumph along dimensions that the engineers did not expect. But there was definitely a triumph in what artificial intelligence can do and what it taught us about what we think of when we think of culture. Netflix, on the other hand, they're not trying to be a real person. They're not trying for any sort of verisimilitude in artificial intelligence. Any recommender engine is trying to replicate some subset of our culture by saying, this is what's in the zeitgeist. You like that? You'll probably like that. That's a statement on culture. And those models are doing very, very well. When I was director of research back at MySpace, we did tons of recommender engines, and they did extraordinarily well. And you come to realize that what you're doing is putting a mathematical model on culture and what people are trying to do. So these AIs can inhabit worlds that we haven't really tried to inhabit. And as we fail, as we try to emulate empathy, as we try to be a personality and we fail, it tells us a lot about what we tried to put into it and didn't quite achieve. If you haven't seen the movie Sunspring and you're interested in artificial intelligence, it is a fascinating example of what we think about when we think about science fiction. So take a moment, look into Sunspring. It's like 20 minutes long. And it's a movie that the script was generated by an artificial intelligence. And it's every trope. It's like everything you expect. You will be surprised by literally 0 lines in there. As a matter of fact, you will often probably think you know where that line specifically came from. But the content that it's trying to manage, or the context it's trying to manage, fails again and again. It has no sense of context. So that was elucidating in the terms that we know that people will put in words and like strings of words, but we didn't bother to think about what context means when we were developing these models. That's actually one of the limitations of the current deep learning framework and the neural net framework that's often bothered me, is that context is really hard to introduce into these models. I saw the speaker, one of the creators of Max Headroom, talk about how Max Headroom was interesting to him because it was an imperfect realization of humanity. That has stuck with me for years. I saw that talk years ago. And an imperfect representation of humanity is actually more interesting and entertaining than a deliberate reconstruction. In the same way that I think Picasso, his imperfect representations are fascinating. And then the DARPA Robotics Challenge about 4 years ago, I had the pleasure of being there. Watching all the robots fall over was entertaining, but also edifying. Like, you were able to see where do humans have control systems in their bodies that the robots clearly weren't designed with. And that's why you see this robot falling over. So when we build these AI and we deploy them, we can create entire worlds where we'll never inhabit. They can be completely digital worlds, completely theoretical worlds. But the intelligence, the decisions that start to get made within those worlds are a form of culture. And we can use that both as entertainment and as reflections on ourselves of what we put into culture and how does our culture germinate into an artificial world. I love this idea. I don't know if anybody would watch that show besides me, but I would watch it all day. I actually experiment with little versions of this, but I would watch it all day, and I'd call my friend who's the editor to make sure that a story comes out of it with this artificial culture, because a lot of it will probably be really boring. But boring to others, not to me. So today we talked a lot about decisions under uncertainty. The curse of big data. We have too much data. We want to marry the fact that we have data with the intuition that we have. We're still trying to answer questions that are outside of our data set. We need to be guided by both instinct and data, because those two things need to intertwine. You can't surrender to just one, right? We still have to be scientists. We still have to hypothesize and test. But so we still have to have that data there, but we also still have to hypothesize, right? Hypothesizing is looking at what we have and going, what's not there? What should be there? And when we're doing this, even in a business analytics point of view, there are these frameworks that have been developed that were called AI at various points in their lifetimes. Some are called AI now, some are not. But they're there and they help us bridge those gaps. And they're very fascinating, and they allow us to address problems that people aren't able to address right now, or people don't have access to these methods, so they can't address a lot of the things that are on their plates right now. Thank you very much for spending longer than I expected listening to me talk. And I'm going to answer questions now. I'm going to go into the chat, and please let me know. I'm going to jump in here, and if Molly, if you want to curate the questions at all or anything, happy to do that.
Yeah, Brian, I'm kind of double dutying because I'm alerting people about the Pitch Fest, but that was amazing. I guess let's see. Why don't you go ahead? You're doing a good job at reading the chat. Do you see any in there that came up? Sometimes they come from other places. I can ask others if you don't.
Yeah, let me just take a moment to rearrange my screen. So let's see. I have one in QA, which is the proper channel. What good AI to summarize my business books and extract frameworks from each? So I think that this is a really great question in terms of how do I start learning about this stuff? And somebody asked this in an earlier chat, like, what classes should I be taking? And the field is really broad. I feel lucky that I'm able to address probably a dozen different AI families. But I have that luxury because I have a strong background in mathematics. I studied mathematics. So the first thing my predilection would be, it's like, don't do anything besides math. Just learn math and let your nose guide you from there. And as you get attracted to problems, maybe you'll be interested in measure theory. Maybe you'll be interested in linear algebra. Maybe you'll go straight into computer science, where the compute is really hard. There's a lot to be done yet in quantum. A lot of the quantum stuff is very computer sciencey, but we haven't developed quantum native methods yet, or I don't know of them. They might exist, but I don't know of them. Because quantum can fundamentally do different math than our classical mechanics can. But right now, people are porting a lot of our traditional machine learning and AI over to quantum to make it faster. That's cool. But I'm looking for the first couple of techniques where it's like, you just can't do this on a classical computer. I think that's going to exist in graph theory and graph analysis because of entanglement. But I don't know. You know, I'm hoping to find out soon. So if you're looking where to get into it, honestly, I would say don't confine yourself to one thing, but do take a lot of math. So that's hopefully that question is useful. Let's see. I'm going back up here. I'm going to go from the bottom up. So forgive me. Actually, no, let me go back because I always hate it when my questions get lost. Let's see. Yes, somebody said future is already here. It's not evenly distributed. I totally agree with that. What about changing norms? We talked about that. That's analyzing sound from programming, not conversation in the room by the viewer, right? So yes, so somebody said when we're talking about speech to text, it is the content that we're doing the speech to text on, but you can do speech to text on the conversation being had in the room, which is kind of creepy. So, but it's physically possible. If you turn on their microphone, you can grab their conversation and do analysis on that. I don't know of anybody who's doing that. Perhaps some of the game companies that are doing like the MMOs are doing some of that. But I don't know. I don't know if there's any new analytics that come from that part. Let's see. So with Google search and trends, I'm not sure how to answer that question about Google. So I'm going to move along. If you want to repose it, I'll try to think of something intelligent to say, or just something to say. Let's see. So would fantasy sports become the new real sports in a post-COVID era? I love that question. And I think that there'll probably be a phase of that where people go, oh, well, it's just all fantasy sports. But let's be honest, part of the joy that people get from the fantasy sports is tying it back to the athletes with whom they feel some sort of emotional and personal connection. So you always want that driving data, right? Like we know that your fantasy version of your basketball team is going to win because of some real world data on how your favorite players did. So there needs to be this generative data set that I think is more interesting than just a completely artificial data set. Now, I'm very interested in genetic algorithms and simulation, so it's really fun for me to create these fake sports. That's part of what genetic algorithms do, is they do these tournaments. So I find that fun, but I think that people, because it's entertainment, will still want to go back to some sort of base reality, and see the look in their favorite athlete's eye as he swings the bat or what have you. Okay, somebody said lack of sentience. I think that sentience. Do we have 2 more hours? So what is intelligence? Nobody knows. What is sentience? Nobody knows. We have this feeling that we're the ones with it and screw everybody else on there. If you happen to be some other mammal or fish, it's not your, it's not your domain. Or some people believe that everything is sentient, right? There was this great series of talks that and I remember part of it on PBS about 15, 20 years ago around intelligence. And it must have been longer than that. Terrence McKenna and Stephen Jay Gould were both on this panel. And Terrence McKenna, who's a bit more a bit more frou-frou than I tend to. I'm a skeptic, and I'm not a big fan of Terrence McKenna, but he's an interesting thinker. He said, "Well, what if the sun is sentient?" And Stephen Jay Gould immediately fired back and said, "What would the sun have to think about?" And to me, that settled the issue. It's like the sun doesn't have to think. It doesn't have to make decisions every day. It's not deciding to have massive gravity. It's not deciding to create fusion, right? It's just there. It's just an object. It doesn't have to decide anything. We as humans have to make decisions because we're being, nature is attempting to murder us every day, right? So we have to think. Other things that have to think, if you create a pressure, you'll probably create something that looks a little bit like sentience. Eventually, it'll become sophisticated enough that it'll surprise you. Now, in the book I mentioned earlier, I actually wrote a mathematical definition of what I believe intelligence to be. And I won't go into that. It's just a working hypothesis for when I'm looking at data. It's not like a general theory of what intelligence can be mathematically defined at, but it's a very fascinating topic. AI cannot understand the intricacy of human behavior. Very, very, very true. Not yet, maybe never. Even when it does, will we recognize it and acknowledge it? Will we say, hey, yeah, sure, you're just like us? I doubt it. Let's see, somebody said you enjoyed the talk, thank you. What is the least mathematical type of cybernetics? So cybernetics is basically the theory of control. So anything around control, depending on how sophisticated your system that you want to be involved in, anything around control can be anything like dampening vibrations on an airplane wing. That is a control system. Information communication between two systems, like a lot of cybernetics came out of information theory with von Neumann and Wiener back in the 50s when they were developing telephone lines. They said, how do I decode a message with reliability? So cybernetics is a very general version of that. I think what I was first drawn to and ended up not going into was the cybernetics of sort of the 80s 80s cyberpunk realm, where we'd have human, direct human brain interfaces, where you'd be able to read nerve impulses and transform those into data. Now that's beginning to happen today, and I'm thinking maybe I should get back into that because it's super cool. But it's so broad. I think that you want to think about systems that are interesting to you. The systems I studied most in college were ecological systems, like kelp forests and oak tree stands. And I did a lot of what you'd call dynamical control analysis of these systems. And I still find those fascinating. So really, if cybernetics is interesting to you and you think back into yourself, what is that? Well, it's studying how systems interact, the information they exchange, and how they exert control and influence over each other. So that's a lot of different fields. Let's see. Is this a concept used to bridge what we know and market-driven, inhibiting wider spread? So AI, like every other field, is very hype-driven, right? It's extremely hype-driven. And there's this notion of the AI winters that come along every 10 or so years, when somebody makes a huge claim that AI is going to transform things and make everything different, and then they don't deliver on it, and then everybody goes, oh, AI is wrong. Oh. You know, and then during that 10 years, and everybody turns their back on whatever system, and they think that AI is dead, during that 10 years, those of us who persist in the field proceduralize these things. So like, you know, 30 years ago, expert systems were considered AI. They're not. 50 years ago, decision trees were considered AI. They're not considered that anymore because they don't seem flashy enough. So like the earliest things of AI were like control systems and perceptrons. Those came out of the Navy's research lab back in the 50s. People wouldn't call the perceptron an AI anymore. That's just not how they're looking at the world. Ooh, we're getting short on time. We're at the 50 mark, so I should probably stop. My email, I'm going to put it right here. Let's see, I'm Brian Dolan. Obviously, I'm at Verdant.AI. So this is me. Just go to www.verdant.ai and find us. And I should be respectful of the next panelist. We're 51 after. Hey, thank you guys for listening. I love to run my mouth about this stuff, so I appreciate Molly giving me this opportunity to talk. I've been listening to the panels all morning. It's been really exciting, really fun stuff. I've been on for the past couple of days, so I'm just delighted to be here. And thanks for letting me talk about math. So I will go into my hole now.